Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on CCUS, carbon capture utilization and storage. And in this video, we'll be talking about seal characterization for CO2 storage. In previous two videos, I have talked about aquifer characterization and reservoir characterization. Aquifer and reservoir that will be used that are proposed to be CO2 storage. And now, how about the seal? How about the cap rock? Okay, so yeah, this is another very informative, helpful table for us to guide us when we are doing seal characterization. It's very simple, but it's very informative and it's very helpful. I take this table again from this very good source. Okay, CO2 Storage Atlas, Norwegian North Sea, Norwegian Petroleum Directorate. It's a very good atlas. You can read it, and it's very informative if you want to know about CCUS, especially in Norwegian North Sea. Go download and read it. Okay. All right. So again, this is our table. This is for sealing properties characterization. Here we have three categories. Either you will have high or good seal property, and then poor or low sealing property, and lastly the unacceptable one. Okay, so here we have high property, low property, and unacceptable. All right, so the first one is the sealing layer itself. You will get good score. The seal is considered good, strong if you have more than one seal. Okay, but if you have only one seal, it's still considered low. But if you have like this, no known sealing layer over parts of the reservoir, then actually it is unacceptable. Because if there is no known sealing layer over some parts of the reservoir, then that spot, that area, or those parts, those areas can be the weakest points from which the CO2 can leak, maybe even to the surface. Okay, so you must be sure that your seal, at least one seal, already, cover all parts of the reservoir. If you want your reservoir or your aquifer to be a proper CO2 storage. Okay, so that's very fundamental. And the second one is the properties of the seal itself. If it is proven pressure barrier of if the thickness is greater than 100 meters, then of course it is considered good, a good seal, high seal. But if the thickness is still below 50 meters, be careful, it's still considered as low, at least in the North Sea. Okay, so yeah, make sure, or you need to prioritize the seal with thickness greater than 100 meters. And then you need to also characterize the composition of the seal. Okay, so you need to do some measurement. You need to take samples, core samples, or at least cutting maybe of the seal rock, and you need to do the composition measurement. So if you have high clay content and if it is homogeneous, then it is considered a good seal. It has high sealing properties. But if it is silty or if it has silt layers, then it's still considered low. It's still considered as poor sealing properties. Okay. And then you need to be careful also about the faults. If you have no fault, if you have no faulting of the seal, then it is considered as good barrier or good seals for your reservoir or for your aquifer. But if you have big throw through the seal, all right, big throw through the seal, then you basically have poor seal properties. However, if you have like this tectonically active faults, then closed book it is unacceptable. Okay, that seal is not good at all. So it is unacceptable. Okay, you need to reject that. You need to find other reservoirs or other aquifers with better seal properties. And then other breaks through the seal, like fracture, for example. If you have no fracture, then of course it is a good barriers, good sealing properties, good cap rock. But if you have fractures, if you have sand injections, slumps at the seal itself, then it's considered as, poor seal properties. But if there are active chimneys with gas leakage, then it's no brainer. It's not a good seal at all. You cannot rely on that seal. Okay. So if you inject CO2 underneath that seal, maybe you have reservoir there and maybe you have aquifer below the seal, underneath the seal, the cap rock, then basically the CO2 can and will leak off. You will have very low CO2 containment, and CO2 is a very important parameter in the performance of CO2 storage. Okay, so basically talking about seal, talking about cap rock, we are talking basically about the CO2 containment. Okay, remember we have storage capacity, injectivity, and containment. Those are three most important parameters you know, to determine the performance of your CO2 storage operation. And one last thing is wells, exploration or production well. No drilling through the seal? Of course, it's considered as a good seal. It's virgin seal. So if you have no wells penetrating that seal, then yes, it's considered a good seal. If you have high number of wells penetrating through that seal, then it's considered basically not a good seal for your CO2 storage. But we don't have anything unacceptable here. So maybe if you have 10, 50, there is still bargaining point. Okay, but you need to make sure, you need to be aware that in the first place, it's not a good properties. It's not a good sealing properties. It's not a good seal. It's not a good cap rock, basically. Okay, so I think that's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching and see you again in the next CCUS videos. Thank you.